Good afternoon, ladies and gentlemen. Many thanks to the Velux Foundations for being here. It's a great honor and a pleasure to be giving this lecture in our sister institution and with such a friendly crowd. So I'm very honored to be here. Many thanks to all. And indeed, the idea today is to talk about Daylightful dynamics and maybe more specifically about the work that our group has been conducting in the last few years. The research group is called the Laboratory of Integrated Performance in Design. So what do we do? Well, of course, we start with buildings, and a building has a context, an immediate one and the broader one. And so what we really do in this lab is to try to connect these different scales with one another. But something that we particularly do with regards to daylight is try to connect them to the occupant as the main receiver and the main witness of this daylight in our spaces. So if we take the building as one entity, one thing that is obvious is that daylighting changes all the time in a very predictable way as far as sun course pattern is concerned, in a much less predictable way as far as weather patterns are concerned, with the cloud cover changing all the time, which brings a dual kind of dynamics to spaces, and this is something that we particularly enjoy with daylighting, and I think this is something we should celebrate first and foremost. And so once we consider the building as having an envelope that allows this daylight to come in, we can start caring about the occupant, who will experience changing daylight over time, depending, as I said, on weather, time of day, time of year, etc. And so the idea is to look at these changes and try to make them not really predictable, but maybe bring in some ways to anticipate how these dynamics work over an entire year or an entire day. And so how we do that in practice is to try to move beyond, let's call them mainstream performance metrics, things that have been studied and used for many, many years, decades in some cases, which typically relate to basically having an illuminated space, and this is based on usually illuminance as the quantity, but also in terms of avoiding discomfort with glare risks that are typically rather static in how they are considered. And of course, there has been a huge amount of research and development, especially in simulation, regarding energy implications, especially as they pertain to solar gains, but not only. However, if we want to look a little beyond that and start to look at what this means in terms of physiology, health, behavior, and how a space is perceived, it opens up other research areas that are actually what we try to focus in our research group. And so we really are articulating this research around three pillars, which kind of push the limits of what we do currently a little further. The vitality, so this is related to health, emotion, related to how well one likes a space, so to speak, and comfort. And so I would like to look a little further into these aspects by illustrating them through ongoing research in the lab. And so one project, for example, led by Georgia, who's actually in the room, looks at interaction effects, something that hasn't been looked at so much, actually, between what we see and how we feel thermally. So could it be that, depending on the color of light, we might feel slightly warmer or cooler when actually, in reality, there is no change in temperature? And to illustrate that, we are borrowing from Studio Olafur Eliasson and his beautiful rainbow panorama. So if you look at this image and kind of consider yourself in this space, maybe, maybe not, depending on the color that you see, you might experience a slight difference in your thermal sensation. And this is something interesting to look at because it might change a little bit how our comfort criteria should be, and that to make them dynamic as a function also of the visual condition. Same question pertaining to glare. Could we be more sensitive to glare in a hot environment, or whether we prefer certain environments or other depending on color? And so what Georgia is doing is trying to expose about 100 subjects, sometimes dozens anyway, to different daylighting conditions, and then ask them to do tasks and ask them to answer some questions to see if there is this effect, even though they might not notice that temperature has or has not changed. On the other hand, still about these dynamics of behavior and perception is visual comfort and glare. And here, the idea is to look at where we actually look when we work. So we may consider that we always look at our screen because we are very concentrated and we focus on what we are supposed to do. However, this is not really the reality. When we actually monitor where we really look everywhere, even when we work. And maybe with a differing frequency and depending on the task, but also depending on the lighting conditions. And so thanks to collaboration with psychophysicists and eye tracking technology, we can see that when we think, we look pretty much everywhere. When we respond or type, we obviously look at our keyboard and screen. But when we talk on the phone, we will have a much broader distribution. What you may have noticed with all these distributions is there is a bias towards the left. And what happens in the left? There is a window. So what we noticed with these kind of studies that were run by Mandana are that there tends to be an attraction towards brighter areas, window areas, unless they become so uncomfortable that you start to move away and want to avoid them. And so to illustrate this, one way to represent this, so to speak, was to take the Neubau house, which is actually built in Miami, move it to Reykjavik, which can do that with simulation, and then represent for each and every one of these glare sources the shift in view direction as a result of the glare source. And so over a day, a long summer day in Reykjavik, we will have, first of all, a lot of glare, but also a shift towards the left to avoid that excessive daylight. However, in the winter, very short day, you will see that there is also a shift still towards the left, which is actually where the reflected daylight came and therefore was not disturbing enough and was more playing the role of an attractor than of an avoidance. So, So there are many new avenues for comfort that should be explored and that we are currently exploring as well. On the other hand, as far as vitality is concerned or health, the idea here is to look at what actually got a Nobel Prize very recently at the University of Lausanne, the fact that we have another photoreceptor in our eye that is not responsible for vision, which is the melanopsin, and which is responsible for the light-dark cycle, for our biological clock, so to speak. And so here we are really looking at non-visual responses, meaning nothing to do with the retina, but another photoreceptor still hugely important in regulating our circadian rhythms. And so there are really two pathways that we are talking about. The indirect one, which is responsible more for the phase-shifting effects, so this is about timing. But on the other hand, there is also a direct pathway which looks at the direct effects, such as alertness, but also melatonin suppression at night. We only produce melatonin at night, and performance. And the alertness is something that we would like to take a particular look at, because during daylight hours and when we work, it would be really interesting to know whether we can embrace this concept further and actually think about spaces also in their health potential. So when we look at this a little closer, we realize that there are basically 5 factors that are really dominant in describing this non-visual system, and what makes them interesting but a little difficult is that they are very different from the visual system. So these are intensity, the amount of light, wavelength, color, duration, how long we are exposed, timing, at what time, and history, so what you were exposed to before. And so in a nutshell, this non-visual system shows that, or photobiologists and neuroscientists like Aki told us or helped us understand that higher levels are more effective, blue light is more effective, but this is actually only true in a dynamic way. That very counterintuitively, intermittent light is almost as effective as continuous one. The timing is, of course, crucial in terms of circadian rhythms, and we adapt to changes in light exposure. If we are in a very bright environment, the effect of an additional light might be smaller than if we are in a very dark environment for a long time. So what we came up with is a computational model or a mathematical model that is trying to make the link between these factors that we can consider as the inputs and what this means in terms of health potential as the output. And so what is important to note is that we have to differentiate between two systems: the direct pathway, which is really about an exposure to a light dose, and the phase shifting effects or circadian timing. And together, they will tell us something about the health potential. So again, trying to represent this in an understandable way, we took the same example, but this time are running a summer day as far as this health potential is concerned. And you see that these two curves are now moving apart from each other, which is not a good thing. It means that there is a little bit of a kind of a jet lag caused by the timing of light, whereas during the summer day, we do achieve the required light exposure accumulated over the entire day to feel alert and healthy. However, during a winter day, too short, even though very extreme, the phase shifting will still happen, but the light dose will not be sufficient to reach this minimal dose, so to speak, to feel healthy, which maybe is not so surprising in a winter equinox, winter solstice in Iceland. Now, the third pillar, as I mentioned before, is related to emotion. And in this case, what we take a particular look at is to celebrate contrast as something that is sometimes desirable. When we only look at daylight distribution from a perspective of visual comfort and illumination, we might forget that actually we may want to have some sunlight pouring in, some contrast, some moving shadows, and that this is actually something that is desirable. We have beautiful examples, numerous examples of architecture that celebrate this effect, and by trying to look at contrast as a way to speak or to reveal this kind of effects, we have this range of spaces that you will all recognize: the Institut du Monde Arabe, the Serpentine Pavilion, the Neugebauer House again, the First Unitarian Church, and the Menil Collection here. And therefore, you can see that if we start to look more closely at how to represent kind of the amount of light and dark that we have in these scenes, and we look at them over time. We have days of the year over here, and hours of the day over here. In the Institut du Monde Arabe, we have so much shadow, so much little shadow patterns moving everywhere, that over the entire year, we will have this great excitement happening, whereas this will happen mostly in the afternoon for the Serpentine Pavilion, same thing for the Neugebauer House because of the orientation. However, and this is of course desirable, there will be a much more calming environment in the church or the museum. And so the idea here is to try to make a connection between contemporary architecture scenes, daylit scenes, and try to look at them from the perspective of how much of this contrast is happening in these scenes. But where this is very intuitive when you look at one image, it might be less intuitive when you start looking at an entire year or at the effect of weather and season. And so to do this in a scientific way, we are still a research group. And this was the work of Shaban Rakasel in particular, whose picture you see here, but you can meet her in person, is to look at several spaces in random order and ask hundreds of people to answer questions about these spaces, and especially looking at what they would say in terms of using adjectives. And we can see that there is actually a nice consensus of people regarding, for example, that pretty much everyone, or the vast majority, will consider the Serpentine Pavilion as non-uniform, varied, direct, complex, exciting, and stimulating, and the opposite in the First Unitarian Church, which says nothing about how nice they are. They may both be absolutely stunning and successful. It is just a way to qualify the atmosphere, or trying to put some adjectives to these. And this consensus shows us that that might be a useful thing to do. On the other hand, we have to extract some number, even though it should be hidden, because it is not about judging a scene, but it is really about trying to extract some number. And so there, Chevy developed an algorithm that is able to extract, based on vision science as well, this MSC value. And so, again, in an attempt to make this a little more accessible, the same scene, it will be the last time you will see it, is showing here the amount of contrast. So we are not talking about a real rendering. You will notice that it's quite different from a rendering, but by wherever there is a switch from dark to bright. And this, the amount of switches, so to speak, will determine how the curve looks like. With December 21st day, of course, it will be much denser, but maybe the amount of contrast will be much higher, however, for a much shorter amount of time. And so this is yet another way to look at daylight than the other two, despite the fact that we looked for the same day, from the same point, in the same house, at the same location, we still see it from three very different ways. To go even beyond that, and this is the work of Cynthia Camillatore, who's also in the room, is to look at not only contrast, but also the composition in the space and how these light and dark patches, so to speak, are distributed, compose a scene. And so in this case, the idea is to ask people, again, to qualify what they see and to use the same vocabulary in a more qualitative way, so to speak. And so applying a color scale, what might be surprising or not is that for the exact same amount of open area and therefore same amount of light, people much prefer the irregular pattern. So in a very boring space, basically a shoebox, the fact that the window has something surprising in it makes them find it actually exciting, complex, interesting, and pleasant, despite the fact that we, as again, are in a shoebox. And so this is very interesting to note and was a kind of a first step into looking at further scenarios. And so Cynthia derived patterns from a large number of actual architectural buildings that had screens and patterns in their projects, and asked a large number of designers, the number is increasing because it's an ongoing study, about what they, how they would qualify the patterns, whether they are exciting or calming. And what is interesting to note here in this gradient is the complexity of the pattern, but also the irregularity of it and the context. Should it be a space for socializing or should it be a workspace? This will have a very different impact in what people say about it. So the most exciting ones were these. Maybe you agree, maybe you don't. And the least exciting were those. The most calming are those. Maybe the study will change after we'll reach the 100 people. And the least calming was this one. So this gives us an indication, again, of pattern preferences. Now, if we want to bring people further into experiencing the space a little closer to reality, sometimes when it's built, but sometimes it isn't yet, we can use virtual reality to have a proper space experience. And so the workflow there is to go from a virtual design, a 3D model basically, get images out of it, and they should be representing, as far as possible, the actual space. This is the Ryerson Student Center in Toronto. And so by bringing these images into a virtual reality device, we can immerse people in this kind of space. Now, the interesting side is that then you can, for example, compare an overcast situation with a clear one and not have to wait for it to actually happen. Of course, this is more useful when the building may not exist yet, or when you have to retrofit it or make a diagnostic about how it's working. And so here you just saw the overcast sky now compared to the clear sky, and this not only allows you to immerse yourself in the space, but as researchers, we can also get a glimpse of where you actually looked and what you found maybe more interesting to look at. So we get closer and closer to being able to discuss both what it looks like and how we can quantify the performance or have some expression of what we can say about it more quantitatively, although we do speak about aspects that may have a qualitative nature inherently. And so if we look at how the scene would look like if you were wearing these virtual reality glasses, we can see that virtual interest, the video seems to be a bit heavy, visual interest is very high when you have a lot of contrast, and vertical illuminance is getting to almost unacceptable range, whereas discomfort glare is almost going to reach its maximum. So this is a way to really have this combination of performance analysis and experience of the space. But this is all done in a lab, in darkness of science. And so the idea would be is actually to bring this closer to practice and be actually usable or useful to practitioners. So with the same 3 pillars that I was mentioning before, the idea is to propose this as a toolkit, as a support for making decisions when this may be useful. It probably is not useful for many architects, and we have certainly one in this room for whom intuition and experience are enough. But in many cases, this may be useful to embrace as an added information to maybe refine decisions, especially when we try to talk about whole year or whole days and seasons. And so if we go back to the 3 pillars and we compare these 2 same spaces, we may wonder if this is going to be calming over the year, exciting or maybe less exciting when it's overcast versus clear sky. And so to do that, the workflow, which I will spare you, but that Chevy has developed, is to go from fisheyes, tone map fisheyes, to get them into every view direction, and then finally extract the information that we want from it. Thanks to this study that we did with the 100 people, we were able to, or Chevy was able to, make this distinction that is based on the probability of response, let's say, between exciting environments or scenes to look at versus calming ones. And then we see that we are closer and closer to be able to actually get this into an architectural design process. Same thing for health. This algorithm was developed so that we can have a somewhat unique response to an input that is manageable, and therefore to have another type of a workflow. It's different, especially because it's accumulated. Once you have to accumulate this exposure over all the hours of the day to speak about health potential and vitality or subjective alertness. Here again, the idea is to combine both the amount of light and how long you're exposed to it to get some kind of a threshold, and use that to define whether somewhere in the space, if you were to stay there for the whole day and look in that direction, would have a high health potential or not. And then finally, for comfort, the idea is to have a Goldilocks zone that is not too bright, not too dark, that is just right, and therefore make sure to avoid disturbing glare, but still also avoid too dim spaces if the idea is that daylight is of significance in the space. And so again, we have yet another workflow that is still similar in the sense that it is based on view direction to extract comfort and glare risks. And here, that means that the scale is also slightly different, and we can differentiate very problematic areas that have a too high level of glare to somewhat problematic, perfect, so to speak, meaning bright enough and no glare. This is moderately okay, and this is probably too dim. And so we can now bring this into analyzing projects. So we took the Ryerson Student Learning Center again, that was designed by Snohetta. Some of you may have visited it in real. And the idea here is to look at 2 floors in particular, what they called the beach, very pleasant space, beautiful daylight. It's the one that was used in the virtual reality demonstration, and what they call the forest, office spaces surrounded by shared ones. And so the idea then is to take any space, any place in the building, and look at these different view directions and extract from there a value for emotion or vitality potential, and then plot it so that we can have a representation of this performance on a plane. So if we look at emotion over time for January 13, of course, the emotion potential or the calming versus exciting balance will change a lot, or change a bit, but we can see that definitely the workspaces are generally calming, fortunately probably, and the rest is very exciting in January. On the other hand, looking at vitality, we have the same kind of contrast, so to speak, between workspaces and social spaces, meaning that those working in these cubicles probably should spend some time in these areas over the day to make sure that they have the right exposure to light dose. And then for glare, again, there is, without surprise, an accumulation of glare mostly at the windows and much fewer in the back of the room. We can also compare spaces to one another and look at these in a synthetic way by getting all the points together and talk about the percentage of the entire space, considered space, that has, in this case, an exciting component, or in this case, half of it would be calming. Same thing for health, with, again, a huge majority of healthy points in the beach, whereas you have this split in the forest environment. So this is still at the research stage, so to speak, but we have now made the step to bring this really, or trying to bring this really into the design, to the design community, and have this as a tool that can help designers and help us offer consulting services to that. And so we will take two examples here to illustrate these tools. So the first one is the Drexel Building in Minnesota, in Philadelphia, sorry, the office is in Minnesota. So here the idea is to be able to look at different moments of the year, of course, as usual, and to have a very interactive exploration, let's say, of the space. In this case, we just saw vitality, we now saw emotion and now comfort. And so for every one of these points in space, in a very interactive way, we can explore different moments of the day. We can go back to vitality for this particular floor. We can change floor and then sort of enable the analysis that was also done on the second floor, which includes an atrium here and has all these other spaces as well. We can see that there is, of course, a higher level of vitality close to the windows, but what is interesting here is that we have a lot of excitement further from the windows, and this would be maybe counterintuitive, knowing that there is more glare towards the window. So the idea is to really separate these different perspectives so as to look at them as complementary to one another. And so we can also get inside the space. Soon we will be able to have renders as well, and then you can start to kind of play with the performance of this space by being really inside it, looking at the overcast versus clear sky conditions, and looking at the three different pillars of performance that I was mentioning before. Another example is, this is a residential space that has multiple layers, multiple floors. This is in Chile, so what is interesting is that the summer will be where you have or our summer will be where you have the least amount of light. And in terms of vitality, as you can see, the months of November, December, and April, June are really the more healthy ones. But generally speaking, there are so many windows in that house that the levels are definitely achieved. The third example you should recognize are the thermal baths in honor of another Daylight Award laureate. And here we dare to take that example just because most of us probably have taken a bath there. And so the health potential is huge. There are enough windows and there is enough ambient lighting to get the dose that we need. What is very interesting is how calming it is. Probably not surprisingly for a spa, and so this is actually a purpose. There is one exciting moment here at this particular hour, because there are slits in the roof skylights, so to speak, that let the sunlight in. And here we have an exciting but also somewhat glary swimming pool, so you should wear your sunglasses over there. But the combination of being glary doesn't necessarily mean it's not calming. It is calming, so the environment or the atmosphere is pretty much the same everywhere, or the one that Peter Zumthor wanted, and this analysis only confirms the excellence of this piece of architecture, which was a bit bold to take, but it's nice to see a space that we actually know. So the next steps in these developments will be still to include more conventional or traditional metrics, such as illuminance-based task illuminance, and represent them in the same way, but also to be able to compare different design options easily, and probably most importantly, to really actually get back to the user or occupant experience, to actually talk about how a space is lived. And here, the idea is to look at a path or the day of someone, let's say a graduate student, and if the graduate student has the opportunity to spend enough time in these areas and work mostly in these shared spaces, the dose of light exposure might be enough for that grad student to feel healthy, whereas the poor assistant professor might spend all her day going from the bathroom to getting a sandwich at the cafeteria and back to her office, and might not reach the healthy dose that she has. So to really use this kind of approach to get one step further into the human and occupant experience. Same for the emotion, of course, where again we have the lucky grad student, pun intended, that has the opportunity to maybe go outside or go close to windows and work where she wants, where you have the assistant professor only getting to work, small break, and then going home. So the idea is really to have this at the service of architects that want to dig a little deeper into the dynamics experience of daylight in their spaces. So to recap, the idea is to always keep the three scales of a building in mind when we do our research. We know that the context is hugely important, the solar and sky context, but also the urban context, and then to look at the building as a whole, but also to not forget that the reason we build buildings are for occupants, and therefore to really care about the human scale, maybe first and foremost. And along these lines, the three pillars that we are really working on at Lipid are those three that really relate to the human scale, but all have to be dealt with regards to responsible energy performance, obviously. And then to bring this closer to practice, we now can also offer more a service type of approach where we can bring these tools into the design community. So all this work wouldn't be possible with a wonderful team, some of whom are in the room. So we have doctoral students, postdocs, scientists, and alumni that all were amazing contributors to this broad amount of work. The website of the lab is here. The one of the kind of service approach is there. And so they each work on some of the pillars, sometimes 3, 2, 1. It depends, so it's a highly interdisciplinary laboratory. And to end, I would also like to thank the foundations and funders, believers in this research, without whom this wouldn't be possible. And last but not least, I would like to thank you very much for your attention.